Good morning to Canada. Greetings from Germany. My name is Jörg Hammerich. I'm from IKN company, and we have participated in the Minnis competition for carbon capture. So thank you very much to be part of your nice event, and we'll try to explain you some very basic stuff of the calcium looping process, which we propose for the Minnis plant to be used. Okay. A few words to the IKN company. The company was founded in 1985 in Germany as a specialist for clinker coolers, which is on the hot end of the rotary kiln. And during the march of the time, we have developed forwards from the cooler to the kiln to the preheater tower. We have developed from small projects to big projects, and today we are working as a turnkey supplier for complete cement plants or cement manufacturing lines. And for these complex R&D projects, we have teamed up with the University of Stuttgart and the Politecnico di Milan, with whom we are working together in other development projects as well. And with them, we have done the big job, the Clinker factory in Vernasca, Italy, which will be the basis for our report here. Okay, we go to the basics of the calcium looping. We have one slide. On the bottom right side, we see the rotary kiln and a clinker cooler. On the left, a calciner and a carbonator. And for the cement process, we are feeding the limestone into the calciner. We are adding fuel and heat, and are decomposing the limestone into calcium oxide and carbon dioxide. The calcium oxide goes towards the carbonator and the kiln, and the CO2 is leaving the process on top of the calciner. On the other hand, from the rotary kiln, we are getting the CO2 from the burner, and this reacts with the calcium oxide in the carbonator back to limestone, and we are feeding the limestone back into the calciner, and by this we are making a nice loop. And by that, the process is called calcium looping. So, and I do not bother you with all these other chemical stuff. It is just simple concept here. We continue to a more detailed slide, which shows the calcium looping process for a cement plant. In reality, we see a kiln again, a preheater stack with flue gas, and a CO2 stack on the other side with the calciner. Technical data are shown there on the slides. And the big advantage for the calcium looping here is we are using the same material which is used for cement production. The limestone from the cement production is used for the CO2 capture as well. And we do not need any other stuff, special stuff, just the limestone. And in the same shape as it is used in the cement plant as well. So this is here on the slide, the ideal calcium looping process, an integrated plant, as you would build it in a brand new case, as for a brand new greenfield cement plant. The problem is Minnis Cement is available and 1,000 other cement plants as well, which have been built for millions of dollars each, or $100 million each, and we need some technology which can be attached to the existing cement plants for carbon capture without building a complete new plant. And this is our concept for the Minnis case. We see here on this slide, on the right side, again, on the basic, the rotary kiln, and in yellow, the preheater tower with the calciner, with the cyclone stages, number 2 to 5. And a red line in between, in the middle of the page. And on the right side, the existing preheater strings is existing in double, and we just attach a carbonator and a calciner to the existing plant by taking out the gases from the 3rd cyclone stage and bringing it back into the 4th stage. So the impact on the existing plant is rather minimum. Just take out one duct, bring it down to the new plant, and then bring it back to the the existing plant at an upper stage. And by this we can do it here in different phases and in different stages of the project. Minnis is a real big cement plant. They are making 6,000 tons per day cement a day. And on the other hand, they are producing 5,000 tons CO2 per day as well. And I think nobody for the moment can handle 5,000 tons of CO2 for a utilization project. So it would rather make sense to develop the Minnis case step by step as well. And yes, this is the flexible concept we have provided here for Minnis. And now we continue, let's say, with our case we have done in Italy for Vernasca. There we have built a very similar plant in the surrounding of the city of Piacenza, close to Milan. Beautiful place to be. Emilia Romagna, you have nice ham, nice cheese, nice wine. So a good place for working. And with the Clinker project, we are developing the calcium looping process up to technical levels number 7. So we are close to realization level there. Again, the slides of the calcium looping here. In the middle, we see the existing plant from Vernasca in gray, which is very similar to the plant in Minnis. It is the same supplier. In principle, Minnis is twice the plant which we see here in Vernasca. On the left side of the slides, again, blue calciner, red carbonator. We are attaching them to the preheater tower. And on the right side, we see our 3D model of the new plant, which is to be attached to the existing plant there. Another slide with some photos of the plant. On the left side, we see the preheater tower. And if you look into the details, we see the piping of our new project. On the right side, we see the tower in the state prior to our project, just the naked concrete, a very narrow and confined space. And on the right side, again, the engineering model of the plant, where we had to squeeze all our equipment side by side into the plant. Okay, the next slide for the engineering. We can see here a typical drawing which we have done for the design and layout of the plant. If you see on the details, it is nicely overloaded, many pieces of steel pipings and screw conveyors, cyclones, and all the stuff. And on the center of the drawing, we can see our nice little engineer there, 2 meters in height, and he's rather small compared to all the other equipment we have in place there. Anyhow, from the drawing to the reality, we see a picture from the construction site where all the people, where the workers are assembling our equipment with the drawings, and it looks more than a cement plant now. In total, we have installed there 110 tons of steel, 40 tons of refractory, and the overall plant is 90 meters in height. Some other details of the plant. We see here all the expansion joints in the pipings of the preheater. This is due to the case inside it's really hot. We have temperatures at the calciner 900 degrees Celsius, at the carbonator 600 degrees, and the plant is built at 20 degrees Celsius. And when heating up the plant, we are facing a heat expansion in the worst case scenario of up to 1 meter, where the carbonator is growing in total length, and we have to compensate this with all these expansion joints in every case and every piece of steel. Here in the next slide, we see on the left side of the photo the calciner with some dust chutes and some other small pipes. On the right side, we have the carbonator equipment with all the long pipes, 110 meters in length overall. And this is close to the end already. This is a photo taken by a drone in December last year, where nearly all the equipment is installed already. However, due to the COVID-19 situation in Italy, we had to stop the construction site in February, and the site was reopened only in late of July again. Last week, we have done cut the ribbon ceremony. We have opened the plant officially, and now we are in the process of preheating the plant, and we will do our first test runs in end of October, early November. And this is a slide of Minnis. We see a nice blue plant, the same blue color like in Italy. And the preheater tower is much bigger than the Italian case. So we have a lot of installation room for our new equipment, which can be attached to the face of the preheater. And in our case, IKN and the partners, we would serve as a supplier of the carbon capture equipment. Minnis or others can work as CO2 provider, and a third party can utilize the CO2 for other chemical purposes. And I think now we are done already. Thank you very much for your attention. And from our side, and a special thanks to the European Union, which has funded all these projects here and helped us a lot to bring the technology ahead. Thank you very much.